Here is a data set summarized as a stem and leaf plot. How many values are in this data set? Well, the number of values in this data set, what we have to do is count the leaves. So, and the number of leaves tells us how many data items there are, because each data item is defined by the key, which doesn't look like it was provided here, but let's make one up hypothetically for this problem. So the key, let's say 3 with a bar and 2 is 32. Then that defines our data as, or our stem as the tens place, the leaves as the one place. So the data itself would look like a stem of 3, a leaf of 0. So 30 is the first data item. Then a stem of 3 and a leaf of 2. So 32 would be the second data item. Then stem of 3, leaf of 4, so that's 34, and so forth. We would get all the data items in that same fashion. Which means if we count the leaves, that would tell us how many data items are in the data set. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 here, so that's 18 to there. 19, 20, 21, 22, 23, 24, 27, it's 32. So if we add up the number that exists, that's 32. What is the minimum value in the last class? So the last class is going to be the class with the largest stem, and the minimum value in that class is the smallest leaf. So a stem of 6 and a leaf of 1, so the minimum value in that last class is 61. What is the minimum value in the entire sample? So if we look at the smallest value overall, so the smallest value overall would be in the category with the smallest stem. Whoops, I meant to highlight that. The smallest stem, and of all the leaves there, the smallest leaf. So we have a stem of 3 and a leaf of 0 being the smallest overall, so 30. How many of the original values are greater than 50? So of all the original data values, how many of those are greater than 50? So 50 starts right here, stem of 5 and a leaf of 0. But we want greater than 50, not including 50. So we would count 52 and anything larger than that. So if we add up those values, that's 4 and 3, so there are 7 values there. And that's the answer to the questions.